Splicing panel feeders, the conductors that run from the switchgear to the line side of your panel main, requires careful consideration of safety and adherence to electrical codes. The National Electrical Code, or NEC, provides guidelines for acceptable splicing methods to ensure reliable and safe electrical connections. Firstly, understand that splicing should be avoided whenever possible. Continuous conductors from the switchgear to the panel main are always preferable. However, if splicing is unavoidable due to conductor length limitations, damage, or modifications to the electrical system, several approved methods can be employed. These methods focus on creating connections that are electrically sound, mechanically secure, and properly insulated. One acceptable method is using appropriately sized and listed mechanical connectors. These connectors, often referred to as split bolt connectors or set screw connectors, are designed to physically clamp the conductors together, creating a secure electrical connection. It is crucial to select connectors that are rated for the conductor size, material, and application. The connectors must be listed by a recognized testing laboratory, such as Underwriters Laboratories, or ALL, to ensure they meet safety and performance standards. When installing mechanical connectors, carefully clean the conductors to remove any dirt, oxidation, or other contaminants that could impede electrical conductivity. Apply an oxide-inhibiting compound to the conductors before inserting them into the connector. This compound helps to prevent corrosion and maintain a low-resistance connection. Tighten the connector screws or bolts to the manufacturer's specified torque using a calibrated torque wrench. Over-tightening can damage the conductors or the connector, while under-tightening can result in a loose connection and potential overheating. After tightening the connector, thoroughly insulate it with multiple layers of electrical tape or with listed insulating boots or covers. The insulation must be rated for the voltage and temperature of the circuit. Ensure that the insulation completely covers the connector and extends beyond the exposed conductors to prevent accidental contact. Another accepted method involves using compression connectors. Compression connectors are installed using a specialized crimping tool that applies high pressure to create a permanent connection between the conductor and the connector. These connectors offer a reliable and durable connection, especially for larger conductors. Similar to mechanical connectors, it is vital to select compression connectors that are listed for the conductor size, material, and application. The crimping tool must be compatible with the specific type and size of compression connector being used. Before installing the connector, prepare the conductors by stripping the insulation to the correct length as specified by the connector manufacturer. Insert the conductors into the connector barrel and use the appropriate crimping tool to crimp the connector according to the manufacturer's instructions. The crimping tool should create a uniform and secure crimp that compresses the conductor strands tightly together. After crimping, inspect the connection to ensure that the crimp is properly formed and that there are no loose strands or sharp edges. Insulate the completed connection with multiple layers of electrical tape or with listed insulating boots or covers. As with mechanical connectors, the insulation must be rated for the voltage and temperature of the circuit and must completely cover the connector and exposed conductors. A third option, particularly for smaller conductors, is using twist-on wire connectors, commonly known as wire nuts. These connectors are designed for splicing two or more conductors together by twisting them within the connector. While wire nuts are suitable for many branch circuit applications, their use for splicing panel feeders may be restricted by local codes or the specific requirements of the electrical system. Always consult with a qualified electrician or electrical inspector to determine if wire nuts are permitted for this application. If wire nuts are allowed, select connectors that are listed for the conductor size and number of conductors being spliced. Strip the insulation from the conductors to the length indicated on the connector packaging. Hold the conductors together with the stripped ends aligned and twist them together in a clockwise direction. Then screw the wire nut onto the twisted conductors, ensuring that the conductors are drawn up into the connector as it is tightened. The twisting action and the internal threads of the wire nut create a secure mechanical and electrical connection. After installing the wire nut, give it a gentle tug to ensure that the conductors are securely held in place. If any conductors come loose, remove the wire nut, retwist the conductors, and reinstall the connector. Wrap the base of the wire nut with electrical tape to provide additional insulation and to prevent the connector from loosening over time. Regardless of the splicing method used, it is essential to adhere to the following best practices for splicing panel feeders. Firstly, always to energize the circuit before working on any electrical connections. Verify that the power is off using a voltage tester. Secondly, use only listed and approved connectors and tools. Do not attempt to use connectors or tools that are not designed for the specific application. Thirdly, carefully prepare the conductors by cleaning them and stripping the insulation to the correct length. Fourthly, make sure to apply an oxide inhibiting compound to the conductors before making the connection. Fifthly, tighten connectors to the manufacturer's specified torque. Sixthly, thoroughly insulate all connections with multiple layers of electrical tape or with listed insulating boots or covers. Seventhly, support the spliced conductors to prevent strain on the connections. Use cable ties or other means to secure the conductors to nearby supports. Eighthly, inspect all splices regularly to ensure that they remain tight and well insulated. Look for signs of overheating, corrosion, or damage. Ninthly, keep detailed records of all splices, including the location, date, splicing method, and materials used. This information can be helpful for future maintenance and troubleshooting. Moreover, the National Electrical Code, specifically Section 314.16, provides guidelines on the number of conductors permitted in junction boxes and enclosures. When splicing panel feeders, it is essential to ensure that the junction box or enclosure is large enough to accommodate the conductors, connectors, and any required fill space. Overcrowding junction boxes can lead to overheating, insulation damage, and potential electrical hazards. Calculate the required box fill based on the conductor sizes, the number of conductors, and the volume of the connectors. The NEC provides formulas and tables for determining the minimum box size required for various wiring configurations. In addition to box fill requirements, the NEC also specifies requirements for the accessibility of splices. Section 300.15 states that splices must be accessible without removing any part of the building structure or finish. This requirement ensures that splices can be inspected and maintained without requiring extensive demolition or construction work. Splices should be located in accessible junction boxes or enclosures that are readily accessible to qualified personnel. Avoid locating splices in concealed locations such as behind walls or above ceilings without access panels. Furthermore, consider the ampacity of the conductors when splicing panel feeders. The ampacity is the maximum current that a conductor can carry continuously without exceeding its temperature rating. When splicing conductors, ensure that the connectors and splicing methods used do not reduce the ampacity of the conductors. Select connectors that are rated for the same ampacity as the conductors being spliced. If the connectors have a lower ampacity rating, the overall ampacity of the circuit will be limited to the rating of the connectors. In addition, be aware of the temperature limitations of the conductors and connectors. Conductors and connectors are typically rated for a maximum operating temperature. Exceeding this temperature can damage the insulation and reduce the lifespan of the components. Ensure that the splices are located in an environment where the temperature will not exceed the rated temperature of the conductors and connectors. If the splices are located in a high-temperature environment, use conductors and connectors that are specifically rated for high-temperature applications. When working with aluminum conductors, it is particularly important to use connectors and splicing methods that are specifically designed for aluminum. Aluminum conductors are more susceptible to corrosion than copper conductors. Aluminum oxide, which forms on the surface of aluminum conductors, is a poor conductor of electricity. To prevent corrosion and ensure a reliable connection, use connectors that are listed for use with aluminum conductors and apply an oxide inhibiting compound to the conductors before making the connection. These compounds help to break down the aluminum oxide layer and prevent it from reforming. In addition, use compression connectors that are specifically designed for aluminum conductors. These connectors create a gas-tight seal that prevents moisture and oxygen from reaching the aluminum conductors. Proper grounding is essential for electrical safety. When splicing panel feeders, ensure that the grounding conductors are properly spliced and connected to the grounding system. The grounding conductors provide a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock hazards. Use listed grounding connectors to splice grounding conductors. These connectors are designed to provide a low impedance path for fault current. Do not use wire nuts to splice grounding conductors, as they may not provide a reliable grounding connection. The size of the grounding conductors must be in accordance with the NEC. The NEC provides tables that specify the minimum size of grounding conductors based on the size of the circuit conductors. Ensure that the grounding conductors are properly connected to the grounding electrode system, which typically consists of a grounding rod, metal water pipe, or other approved grounding electrode. Finally, always consult with a qualified electrician or electrical inspector before splicing panel feeders. Electrical work can be dangerous, and it is essential to follow all applicable codes and regulations. A qualified electrician can help you select the appropriate splicing methods and materials, ensure that the splices are properly installed, and verify that the electrical system is safe and code compliant. The electrical inspector can inspect the work to ensure that it meets the requirements of the NEC and local codes. Remember, safety is paramount when working with electricity. By following these guidelines and consulting with qualified professionals, you can ensure that your panel feeders are spliced safely and legally. Following the NEC Article 110.3 regarding examination, installation, and suitability of equipment. Equipment must be installed and used in accordance with any instructions included in the listing or labeling. Firstly, conductors used in electrical panels and related feeders must be properly identified by color code. Secondly, all electrical work should be performed by qualified and licensed electricians who are familiar with local electrical codes and regulations. Thirdly, before beginning any electrical work, always disconnect the power supply to the circuit being worked on. Use appropriate lockout/tagout procedures to ensure that the power remains off while work is in progress. Fourthly, use appropriate personal protective equipment, including safety glasses, gloves, and insulated tools to protect against electrical shock and other hazards. Fifthly, when making connections, ensure that all wire connections are tight and secure to prevent loose connections that can cause overheating and electrical fires. Sixthly, use only approved and listed electrical components and materials that are suitable for the specific application. Seventhly, when running cables and wires, ensure that they are properly supported and protected from physical damage. Eighthly, after completing any electrical work, thoroughly inspect the installation to ensure that it meets all applicable codes and regulations. Ninthly, test the circuit to verify that it is working properly and that there are no electrical hazards. Tenthly, keep accurate records of all electrical work performed, including details about the materials used, the location of splices and connections, and any modifications made to the electrical system. Always refer to the latest edition of the National Electrical Code and local electrical codes for specific requirements and guidelines related to electrical installations and safety. The NEC provides detailed information on conductor sizing, overcurrent protection, grounding, and other important aspects of electrical safety. The NEC is updated every 3 years, so it is important to stay current with the latest edition. The authority having jurisdiction, or OJ, typically the local electrical inspector, has the final say on whether an electrical installation meets code requirements. It is essential to work closely with the AHJ to ensure that all electrical work is performed safely and in compliance with all applicable codes and regulations. Also, maintain a safe working environment by keeping the work area clean and free of clutter. Use appropriate lighting to ensure adequate visibility. Be aware of potential hazards, such as wet floors, overhead obstructions, and nearby equipment. Electrical safety training is essential for anyone who works with electricity. Training courses cover topics such as electrical hazards, safe work practices, lockout/tagout procedures, and the proper use of personal protective equipment.